So today in Algebra 2, we're going to look at how we could solve these systems of equations that we've been dealing with using technology. That's in our Algebra 2 standards. We want to be able to utilize technology in solving things in addition to being able to solve them by hand. So we're going to look at a problem today that we've already done, actually. We already know the solution to this because we worked it out by hand on the first day. I think that we did a system that had 3 equations to it. So we already know what the answer is to this. I did show you one day how we could graph this in 3D, but that is not very easy to look at. Like, kind of makes your eyes crazy looking at that. So graphing is not the technology that we want to use here. The technology that we want to use is going to be Desmos. Desmos has a calculator that we will use for this, and I'm going to show you how to use a graphing calculator today because Desmos is really user-friendly and we really like it. However, on the SAT, you're not allowed to use Desmos, but you are allowed to use these calculators. So I'm going to show you how you can use them so you know how to do that. So the way that we'll communicate both with Desmos and with these Texas Instruments calculators is we need to take the system of equations and turn it into what we call a matrix. Okay, so that word is over here, matrix. It's matrix form. And okay, so here's kind of the thought process. I've mentioned before how mathematicians don't really like extra writing, like that's why they make up symbols for things so that they can like write in shorthand kinda. Well, in solving systems, I kind of got tired of all the variables, like ugh, so many letters to keep track of. So what they decided was that they would take the coefficients and write them in a certain way, and then they won't have to keep writing the letters over and over again. So that's kind of the basis behind a matrix. So matrices, the plural of matrix is matrices. They are written inside little box things here. So what we're going to do is we are going to agree to keep these equations always in standard form. So we're always going to go x and then y and then z and then the answer. Okay, so, and we're just going to write the coefficients. So I'll make a note here. We must keep coefficients all in the same order. So we agree when we're taking it from the equations into a matrix, we're always going to name the x's and then the y's and then the z's and then the constant. So this first equation here is going to become 2. Now, what would the coefficient be in front of this y here? All I see is a negative sign. That would be a -1. So the y's coefficient is a -1. The z's coefficient is a 2. And this is going to be like my answer line. And that comes out 15. So it equals 15. So this line of the matrix is saying this equation without having to write the letters. Okay, so I know sometimes mathematicians take this shorthand stuff a little too far, and you might be feeling that right now. If so, I kind of agree. But it will let us use technology. So there's a silver lining. So let's take this second equation. We're going to go x's and then y's and then z's and then the equals part. So what's my coefficient in front of my x? Well, that would be a -1. And what's my coefficient in front of this y? I don't see anything. Well, that would be an understood 1. It's plus, so it's a +1. Same thing with the z. It's going to have 1z there, and that equals 3. And our last one is 3 x's, and then -1 y, and then 2 z's, and that equals 18. Okay, so what we've done so far is taken our equations and written them as this matrix, because that's what the computer will understand and that's what the graphing calculators will understand. So we're kind of putting it into language that the technology that we're going to use can understand. So must keep the coefficients all in the same order. X, then y, then z, then what comes after the equals. Okay, so let's use Desmos first, I think. So let me minimize this for a second and come over here to Desmos. Now what we're going to do is we're going to go to this Math Tools section and we're going to pull up this matrix calculator. And we are going to, let's close Equatio, sorry about that. We are going to make a new matrix. So it's going to call it A, that's fine. So we are going to input this information here. And it wants us to set up how many rows and columns are in our matrix. So it looks like I have 3 rows and 1, 2, 3, 4 columns. There, so that builds it for us, so we have the space that we need. And then we're just going to enter this matrix. So 2, negative 1, 2, 15. I'm going to go down a line. That was negative 1, 1, 1, and 3. Go down a line. That is 3, negative 1, 2, and 18. Okay, so we've got our matrix entered here. So when you get to the last entry, that 18 there, I'm going to hit, oh no, I'm going to hit enter, and it's going to give me this menu choice. We want the feature that is called RREF. So I'll write that down in just a second. It stands for Reduced Row Echelon Form. So I'm going to hit that button, and I want to find Reduced Row Echelon Form, RREF, of my matrix that it has named A. Okay, now if you look over here, oh, my picture might be in the way. Oh, let's see, how am I going to do this? I don't know if you can see that. Well, I'm not really sure if you can see this matrix or not. So I'll scroll slowly so that you can hopefully see it, and then I'm going to write it down on paper. So it probably would be a good idea if you went on Desmos and entered this matrix so that you could see what pops up there. So let me switch back to my paper here. So what we see when we put this into Desmos is, well, actually, let me write down the steps first. So Desmos, we choose the matrix calculator. Set the matrix size. That's where you enter the rows and columns that you need. And then we want RREF of whatever matrix. It's probably going to be A is the default one. So that stands for Reduced Row Echelon Form. Ooh, how do you spell echelon? I think that's it. And what your computer shows you, let me get this copied down here, is 1, 0, 0, Desmos isn't putting this little line. I'll show you in a minute. 0, 1, 0, 1, and 0, 0, 1, 5. All right, so here's what I'm seeing as a result of reduced row echelon form on Desmos. Desmos does not put this little line in. That line typically means that the answer is what comes next, like that's where the equal sign was in the systems. It's fine that it doesn't put it. So I want to see if you see any connections between what we already know the solution to the system is and what you're seeing here. So, well, I see a 3 and a 1 and a 5. But what does all this stuff mean over here on the left-hand side? Well, remember we agreed that we were putting the x's and then the y's and then the z's and then the equals, whatever came after the equals? Well, let me label these columns for you. These are the x's and the y's and then the z's and then whatever it equals is over here. So if I look at this first row, it's saying that I have 1x, I don't have any y's, I don't have any z's, and that equals 3. Well, that's exactly what we knew, because ordered pairs, remember, also go x and then y and then z. If you look at this second line, it says we don't have any x's, because 0 is in my x's column. I do have one y, so 1y. I don't have any z's, and that equals 1. Okay, yep, that makes sense. In this last row here, I don't have any x's, I don't have any y's, but I do have a z. So 1z is equaling 5, which also matches our solution. So that's good that the technology got the problem right. So that's how you interpret what you get from reduced row echelon form. So that's what each of those rows is telling you. So let's try that on our graphing calculator. So I'm hoping you're going to be able to see this. Okay, I need to move it up so you can see the important keys on here. And see our matrix. All right, so I think this will work. So we need to get that matrix into this calculator. So on these, there is a button that has MATRX. So that's the calculator abbreviation for matrix. They cut out the I, so great. So I'm going to press that button, and it gives me some choices. And the first thing that we need to do is we need to edit what the matrix is. So I'm going to go over to the edit column, and the first one is selected just automatically. So we want to edit that one. And so this is where I'm going to put in how big of a matrix I need. So it gives me my structure. So I had 3 rows and 4 columns. So 3 by 4 is what I'm going for there. So it's giving me my space. So I'm going to get this entered now. So 2 was the first value in my matrix. And then a -1. And then a 2. And then a 15. And if I just keep hitting enter, it goes to the next one for me. So -1, 1, 1, 3. And then the last row is 3, -1, 2, 18. Okay, make sure you hit enter that last time so that 18 shows up in the matrix. So I've got this matrix here. I'm going to go back to the matrix menu. So I'm hitting that matrix button again. And so now see how it says that A is my 3 by 4? That's good. So I've got it edited there. Now I need to do some math with it. So I'm going to select the math menu in the middle there. And if I go down a ways and look through these choices, there's lots of stuff you can do with matrices. Oh no. Aha, I'm back. Not all graphing calculators have reduced row echelon form. So this Texas Instrument does. So the entering process would be the same as it was a second ago. The matrix button is here. I don't know if you can read this or not. Let me hold it up a little bit. Oh, that's blurry. Oh my goodness. So you're going to have to trust me that this button right here, I think I can read that maybe, matrix, matrix, is in blue, so I need to use the blue second key to get to it. So I'm going to pull up the matrix menu. So what we want to do is, I already have the matrix entered as matrix A. It's a 3x4, but we want to do some math with it now. So I'm going to go over to the math column, and then I'm going to go down until I can find RREF, Reduced Row Echelon Forms, choice 8 there. So I'm going to hit enter. Now it opened up a parentheses for me, so it wants me to tell it which matrix to use. So I want matrix A, so I have to go back in that matrix menu. So I have to use second and then matrix again, pull up that menu, and I want matrix A. That's the one where I have my data. So I'm going to choose option 1, which puts an A in my parentheses there, and I'm going to hit enter, and ta-da, that is the same matrix we have from using Desmos a little bit ago in reduced row echelon form. So that's telling us that X is 3 and Y is 1 and Z is 5. So it's good that it gave us the same information. So there's how we graph on there. Now I want to do another problem with you that we've already done. So this is number 3 from this worksheet that we pulled problems from for days. So we have A plus B equals 3, negative B plus C equals 3, and A plus 2C equals 10. So if we want to use technology to solve this, then we need to change it into a matrix so that we can talk to the computer or talk to the Texas Instrument graphing calculator. So to do that, remember we said that we were going to, oops, I made that too long. We were going to keep up here, we agreed to keep the X's, and then the Y's, and then the Z's, and then the equals answer part in that order. Well, here we have different letters. We have A's and B's and C's, but the idea is going to be the same. I'm going to label them A and B and C up above, so I remember what's going to go where. And then I'm going to have space for my answer here. So let's take this first equation, and we're going to change it into this row of the matrix. So I have 1A, because there would be an understood 1 coefficient there, 1A. I also have 1B. Now, I don't have any C's. There aren't any C's. Well, if there aren't any C's, what number do you suppose I should put here for the C's? Well, that would be 0, because there aren't any. And this equals 3. So I'm going to add a thought up here, where we said that we must keep the coefficients, needs an S, all in the same order, X and then Y and then Z and then equals. There's another thought. We must fill in missing variables with a 0. So, like this 0 here where the C is, that tells us that we don't have any C's. So, let's take this second equation and turn it into a second row here. Oh, I don't have any A's in that one. So, that means I have 0 A's. My B's, I have negative 1 as the coefficient in front of that B. And I have 1 C, and that equals 3. And then for my A plus 2C, I have 1A. Don't have any B's, so I'll put a 0 there as a placeholder, and then I have 2 C's, and that equals 10. So I've changed it into a matrix, and I think I'll use the Texas Instrument since that's what you're allowed to use on the SAT, if you would like. They have some that you could borrow if you're going to take that test. So let's see, I'm going to go to matrix, so second matrix. It's going to pull up my choices. I need to edit what A is. So I'm going to edit that. It's still a 3x4 matrix, so I can leave those dimensions the same where it says 3x4. So that's fine. But now I need to change my numbers to a 1, 1, 0, 3 for the first row, a 0, negative 1, 1, and 3 for the second row, and then a 1, 0, 2, 10 for the third row. Make sure you hit enter on that last one. That's an easy thing to overlook. And now let's do reduced row echelon form. So I'm going to go out of this for a minute. I'm going to go back to the matrix menu. So I hit second matrix. And now I want to do some math with this matrix. So I go over to the math column. And what we are wanting to find is reduced row echelon form, RREF. So there it is, last choice there. So I'm going to hit enter. It opens up a parentheses because it's saying reduced row echelon form of what? So we need to tell it what matrix. So I'm going to go back to my matrix menu. And I want that first one there, the one that's called A. So I'm going to hit enter. It puts the A in there, and then I'm going to hit enter again. And here's what I get. So reduced row echelon form of A gives me 1, 0, 0, 2, 0, 1, 0, 1, 0, 0, 1, 4. I like to see the equals sign, so I'm going to put that in there. So what does this mean? Well, remember what our variables were in this one, A and B and C. So I'm going to label those up top here so I can remember. So this first row is saying I have 1A. No B's, no C's. I just have 1A, and that equals 2. So this is saying A equals 2. The second row is saying I don't have any A's. I do have a B. I don't have any C's. So all I have is a B, and that equals 1. And then this third row is saying I don't have any A's. I don't have any B's. My C value is 4. So that's how you can use technology to solve some systems of equations. You've got the Desmos matrix calculator, and we have Texas Instruments, some of the Texas Instruments graphing calculators that can do reduced row echelon form. So I think that is everything. So remember that Jesus loves you, and so do I, so do your math.